Now, you may be wondering why these CVTs are popping up everywhere right now. Of course, you've seen Nissan has really jumped into the CVT bandwagon. GM has now got a new CVT for 2014. Of course, Chrysler's got it. Ford's got it. Basically, every manufacturer out there, for the most part, has jumped into the CVT operation. Well, the reason for that is because of how engines physically function. What it boils down to is in order to get the best fuel economy and the best power out of your engine itself, you have a very narrow band of RPM that you have to operate the engine itself in. So within about 1,000 RPM band. So a CVT gives you a distinct ability to do that. When you step on the gas in a CVT, just like you would on a snowmobile or you would on a four-wheeler, the acceleration that you feel is the pulley ratio physically changing. So the engine goes up to a certain RPM, and it physically stays at that RPM, and the pulleys simply vary the ratio so that they can give you more road speed. So that's the whole idea behind this thing, is to try to improve your fuel economy of the vehicle itself. Now, this is a Chrysler engineering chart that you're going to look at right now. That chart, as you can see, has got a 62 TE on the chart. That's a 6-speed transmission. And, of course, you've got the CVT that's there in blue. One of the things that you guys have seen within our industry is more and more applications are going to more and more speeds. Well, the reason for that is to try to keep the engine closer to its power band. So, as you can see, there are some pretty major RPM variations with this 62 TE that you're physically looking at in this picture. Well, if you look at the blue line, that's the CVT. It comes up to a certain RPM, and we, of course, then maintain at that RPM, and the road speed continues to increase even though we're holding the throttle steady at that point. Fuel economy savings is about 17% as compared to a step-shifted transmission. So that's the reason everybody's jumping on the bandwagon and trying to go this direction. This is a look at this Chrysler CVT. There are 3 versions of it, the CVT2, CVT2A, and the CVTL. Those are all 3 versions of the same unit. You have to make sure you know which one you have, because obviously there are going to be some parts differences between the 3. They're all built by Jatco, which is probably the #1 manufacturer of CVTs on the planet. Jatco builds for lots of people. In fact, the brand new 2014 GM is a Jatco built unit. So again, the bottom line is operation of the CVT is going to be the same no matter who builds it, whether it's ZF or Jatco or somebody else. You're going to simply vary your pulley dimensions to vary the speed and the torque that the CVT can deliver. When one pulley increases in diameter, the other pulley will decrease by exactly the same diameter. That assures that we keep the belt nice and tight. Now, this particular CVT is what they call a push belt. It's different than some of the other CVTs. It actually pushes the pulley from one pulley motion to the other pulley. So it's not trying to pull the belt like a snowmobile would do. It's actually pushing the belt along. When you look at external views of this transmission itself, we're going to give you a look at the whole trans and what you actually see for pressure ports and so forth, pass-through connector. The one thing I might bring your attention to is number 7. It says water to oil cooler. That's actually a water to oil heater. Chrysler, as well as everybody else, is getting on the bandwagon of preheating the oil as it goes into the transmission, especially during warm-up cycles. What's been discovered a few years ago was that having the transmission fluid at a certain given temperature reduced the overall torque it takes to drive the unit, especially cold. So the parasitic drag goes down significantly if you can keep the fluid above a certain given temperature. So that's the job of that number 7 right there, is to actually act as a heater. You guys are going to see the exact same thing on the new Dodge trucks. If you climb underneath the new Dodge truck on the left-hand side, you're going to see some cooling hoses going into that, and those cooling hoses are actually feeding that heater. And then there's some valves and so forth, solenoids that control the flow of coolant for that. So again, not something new here. Toyota's been doing this for a while. Some other manufacturers have been doing it, but you're seeing it on more and more Chryslers. When you look at the back of the unit itself, as you can see the secondary variator and the primary variator. Those are the pulleys. So the variator and the pulley are the same thing. You look at the top of the unit, you can see a pressure tap, you can see your range sensor, and you can see your output speed sensor. So this is like a conventional style automatic transmission where you're going to have a range input, you're going to have some vehicle speed sensors on board, just like you would with other transmissions. Now, the CVT2 is available in two different configurations. One of them is a front-wheel drive, one is an all-wheel drive. So we're showing you a picture of both designs right there. And as you can also see, I'm giving you a listing of the three different CVTs that are actually out there. The CVT2, the A, and the L version, as you can see there on your chart. The torque converter that Chrysler runs in this is a squish design torque converter, very similar to what you'd see in some of the other front-wheel drive cars that are on the market today. I mean, there's several of them that they've done this with. The reason for this, the scrunched down design or squished design, is for packaging. So they can actually get everything in a smaller space. And that's a pretty big issue nowadays because, again, they want to be able to put this transmission in multiple different applications. So bottom line is, very small torque converters, very compact design transmission. As you can see, converter comes in fully locked at about 12 miles an hour, and then they simply vary the pulley size to vary the torque that you need to drive this vehicle. So they don't need torque coming from the converter once the car gets in motion, so they bring the converter in itself and lock it solid. Now, the pump drive, as you can see, is right here off the top of the converter. That's what my big blue arrow is showing you. The pump that they're using in here is a off-axis chain-driven pump, very similar to what you'd see in the new front drive GMs, 6 speeds. Same thing that you'd see, obviously, in the 8-speed Chrysler truck transmissions, as an example, or some of the passenger cars, ZF design stuff. So bottom line is, nothing different here. They do that, again, for compactness, to try to make the transmission smaller lengthwise. The basic operation of the CVT is going to be the same no matter whose CVT it is. You're going to have a couple pulleys and a belt. The belt's made out of metal segments, and the pulleys have the ability to vary their diameters. Now, when I vary one pulley, I vary the other pulley the opposite direction by the same amount. The whole logic behind that is to make sure you keep the belt tension there so that you can transmit the motion from one pulley to the other pulley. When you look internally in these things, one of the things you're going to have to do as far as service is you're going to have to be able to service the belt. You're going to have a special tool in order to service the belt on any CVT, and these are no different. Here you can see I've got the Chrysler tool on here, and it's physically pulling the pulley up against the spring that's inside of the pulley hub itself. So you have to be able to pull that up and make that gap bigger so that you can get the belt in and out. Last year's seminar book, we showed you exactly how to do that. We showed you how to build your own tool if you chose not to buy the factory tools. So if you don't want to buy this Chrysler tool I'm showing you here, you can build your own tool to do the same exact thing. Now, as far as failures of these transmissions, the three most common failures we run into are the, obviously, belt giving us troubles, which is usually then related to fluid level issues. If you overfill one of these CVTs, you will have a belt failure. That's just how it is. When the oil aerates, you lose the abilities to maintain that oil film between the belt and the pulley, and it will damage the belt. So bottom line is, fluid level becomes extremely important, and we normally only think about fluid being a big thing if it's underfilled. Well, on a CVT, it's a huge thing if it's overfilled. So just keep that in mind. Bearings have been the #1 failing item on these transmissions themselves. These bearings are SKF bearings. You may not be able to get them locally. You may have to go to an outside source in order to get your hands on them. Chrysler does not service a lot of parts in this transmission, so you may end up going to other sources to get your parts to be able to fix it. The third issue we run into is valve problems. So bottom line is, make sure you check the valves for wear because that can certainly cause you some troubles with one of these CVTs. Here's a look at the belt. As you can see, the belt's made up of some segments, which are basically little sharpened metal segments like wedges. Now, if you look at the lower left-hand picture, I'm showing you the serrated edges on that. Those serrated edges is what grabs the pulley. So when the belt serrations wear rounded, the pulley won't be able to grab the belt, and you're going to have belt slippage on your hands. The other thing I'll warn you about the belt is typical CVT belts. If you drop this on the floor, you're going to have a zillion segments laying all across your floor. So make sure you take care when you're taking the belt off to make sure you do not pop those things apart, because it will become a nightmare trying to put everything back together. and it's probably just as easy to replace the belt if that happens. The fluid that we're using with the CVT, this is the Jatco fluid, same Jatco fluid that GM is using and everybody else is using. It's a green colored fluid. They call it their CVT F+4. As you can see, I'm giving you your capacities as well as your part numbers for the fluid. The one thing I'll warn you about, make sure you use the correct fluid in these transmissions. Again, you're going to end up with belt troubles if you do not have the right friction compounds within the fluid itself. So my point is, the additive package is totally different than regular automatic transmission fluid is. Fluid level with your CVT itself, just so you know, on the fluid level side, you're going to have a special dipstick. That's the Miller Special Tool 9336A. Same basic tools that we use for the 722.6 type transmission, same design stuff. So the process is the same. This is a look at that dipstick tube itself, or I should say dipstick itself. Notice there are serrations every 10 millimeters. And of course, you'll stick this stick in, and then you're going to look at what your temperature is. Now, I've given you a chart in your handout that when you get your handout open, you'll see that the fluid temperature chart on the bottom shows you that that fluid is going to vary on that stick based on your temperature. So the high means that's as high as it should go based on that temperature. The low is that's as low as it should go based on that temperature. So again, you're going to want to pay attention to the fluid temperature before you obviously put the stick into the transmission and check the fluid level. Again, I cannot overemphasize how important it is that you do not overfill these transmissions. Aeration of the oil in a CVT is death to the CVT belt. You got several coolers on here, as you can see. I'm showing you the cooler in the front of the unit itself. Again, so coolers are no different than you've dealt with before. The one thing that is different is on the back side of the radiator core support on these units. As you can see, there is a valve. That's that number 3 in the picture, the purple thing. That valve block itself is what they call a cooler bypass valve. You're going to find this in a lot of the different Chrysler vehicles. It's set somewhere between 55 and 60 pounds on this transmission. What it does is it allows you to have lube flow when the transmission is cold and you got high cooler pressure. And it also allows you to have a bypass in case the cooler becomes restricted. If you do have a problem with that valve, I've given you 3 common failures that you're going to have if that valve is to hang up. Overheat, lack of lube, or temperature sensor codes, or a combination of those things if that valve is to hang, obviously not working correctly. Now when it comes to servicing the fluid itself, as you can see here, we're going to give you a pan gasket number, oil strainer number. Again, make sure you're using the right kind of fluid and make sure that you have the fluid level correct. The pan, the bottom pan, does have a couple dowels in it. Make sure you line those dowels up as you're trying to pop the pan on. Now, most CVTs do not have pressure taps on them. The majority of them do not. And the reason they don't is because they don't want somebody to obviously put the wrong gauge or hose on this thing and end up with an accident. Chrysler does have pressure gauges on this Jatco unit. So you've got some pressure taps. You can take a look at them. There's actually a whole bunch of them. They do want you to use a high pressure gauge. That gauge, as you can see, is a 2,000 pound gauge, and that also means the hose has got to be capable of the same kind of capacity. Again, using a regular old 300 pound pressure gauge, you'll get a real rude awakening when you obviously hook this thing up to your variator pressures. It won't be a good day for you. When you look at the pump itself, the pump on this particular transmission is a vane style oil pump, just like you'd have in the new rear drive 8-speed Dodge trucks. Nothing different here. It's an off-axis pump, just like those Dodge truck 8-speeds have, just like a 6070 has, like the new Gen 3 6040, 6041s have. So bottom line is everybody's going to this design because of packaging. This is a high pressure pump, and of course it's chain driven by this little bicycle chain. I always get guys asking me questions in the seminars when we're going through this type of pump design. Well, how do you check the chain? Well, there is no check. There's no specifications for chain wear. When you check one of these chains, you check it exactly like you check a motorcycle chain. You pull the chain off and you check for movement within the links themselves. If you view that as excessive movement, then of course you put a chain on it. Here's a look at the pressure testing specs that we're going to have. As far as the ports are concerned, and I'm also going to give you a chart that actually has the specifications on it. Number 1 and number 5 port, as you can see there, those are your primary and secondary variators. So that's the pressure going to the primary and secondary pulleys. Those are the ones that are going to be high pressure. You got 2 clutches, number 2 and number 6, your reverse clutch and your forward clutch. This transmission only has 2 clutches, one to move you backwards, one to move you forward. You got a couple torque converter pressure ports, and you, of course, have a line pressure torque. So nothing razzle-dazzle when it comes to pressure testing. You will have a chart in your handout showing you what the pressures are supposed to be. So you can physically take a look at the pressures. Again, make sure you got the right gauge hooked to the vehicle. Now the planetary that we use is a very, very simple planetary. It's only there to allow this transmission to back up. We all know that you hold a planetary stationary to get your reverse out of a transmission. Well, this is no different. Your reverse clutch wraps around that number 1 planetary carrier right there, locks it to the transmission case, and the sun gear, of course, drives those pinions, which in turn spins number 3, which is your ring gear, backwards. So bottom line is, it works just like any other transmission. You turn the clutch on, you drive the sun gear, spin the pinions backwards, or spins the ring gear backwards. One thing I will bring your attention to, I put a note in here on the slide, as you can see, pulley ratio is locked in reverse. Now that's intentional on this transmission, and many of these CVTs are like this. In fact, almost all of them are. When you in turn choose reverse, they do not want a vehicle overspeed condition. They don't want a situation where you're going 60 miles an hour backwards. So they lock the ratios on the pulleys so that you can't back the car up too fast and get yourself in an accident. So again, that's done in reverse. It's not done in the forward gear. The 2 clutches we talked about, one is the forward clutch. Again, that's driving my sun gear. And one is going to be the reverse clutch. That's the guy that's going to be holding the planetary carrier. As you can see, very simple clutches, nothing earth-shattering or unusual about it. The repair of this CVT, other than getting the belt off, is about as simple as you're ever going to get. There really isn't a lot here. Now, when you get the electronics and the valve body, it gets a little more complicated. But as far as the mechanics of this thing, there's not a whole heck of a lot going on here or anything that's really complicated. Final drive, as you can see, we're giving you idler gear ratios, final drive gear ratios, your overall ratios. So the overall ratio is going to vary depending upon what your pulley position actually is within the unit itself. As we talked about before, you got a couple different ratios that you may run into. Your CVT2s and CVT2As, they have a 6:10 ratio, and of course the CVT2Ls, they're an 8:14 ratio. So again, they're going to be varying ratio depending on what kind of vehicle this thing actually fits into. So you got to watch the parts interchange between an L version versus the A and the standard CVT. All right, so now let's talk about the meat and potatoes of this operation. This is your stepper motor. Most CVTs have these stepper motors on them. A stepper motor works exactly like an idle air control motor works on a fuel injection system. It's basically like a reversible drill. You can screw it one way, which screws it out. You can screw it the other way, which screws it back in. It moves in steps or sequences. When you in turn move the stepper motor, which is number 1, that moves that link, which is the number 3. That link, as you can see, is attached to the ratio control valve, which is number 2. As that stepper motor moves, it moves that valve, which in turn changes the pressure that goes to your pulleys to change your ratio on your pulleys. So the bottom line is the variator position, in other words, how big the pulley actually is going to vary depending upon where you actually put that valve, which is determined by the stepper motor. This is a look at the hydraulics of the thing. I think you'll see it's fairly simple. The red circle that I put up there on the top shows you the stepper motor and shows you the ratio control valve. And so the ratio control valve is controlled by the stepper motor. That ratio control valve also controls pressure to the primary pulley, which is number 6, and of course to the number 4 valve, which is the secondary valve, that in turn controls the pressure to the number 5 pulley, which is a secondary pulley. So what I'm telling you guys is really simple. As you move that ratio control motor, number 1 at the top of the page, what's going to ultimately end up happening is the pulley size number 6 and the pulley size number 5 are going to change. When I increase the diameter of number 6, I will decrease the diameter number 5 by exactly the same amount. That maintains then the tension on the belt, so we in turn do not have slippage. If I reverse that operation and I increase the size of number 5, I have to decrease the size of number 6. So these guys are moving inverse of each other, or backwards from each other. There will be 3 modes of operation for this CVT. Very, very simple. You got a ratio hold mode. That's used in reverse. So when you choose reverse with this transmission, the ratio control motor, in other words, the stepper motor, actually goes to a fixed position. That fixes that number 2 valve in a specific position, which in turn then controls the pressure to number 4 and number 5 pulley and locks them in a fixed position. Again, the big issue in reverse is we do not want to have a situation where the guy can drive this car too fast in reverse and end up in an accident. So the ratios, as you can see, is a torque multiplication ratio, because the pulley diameter in number 4 is effectively smaller, and the pulley diameter in number 5 is effectively larger, as we're showing you in the picture. So you're going to get a lot of torque, but not a lot of speed. If we want to drive the car forward and we want to accelerate from low speed to high speed, this is how it does it. The number 1 up there at the top, which is your solenoid, that's your ratio control stepper motor itself. That stepper motor, as it moves, we're moving it to the right in this picture. That's the yellow arrows that you see there. As we move it to the right, that also pulls on that link, number 2, which controls your ratio control valve, number 2. That controls the pressure on that number 4 pulley. At the same time, you got that red oil pressure coming down to the number 3 secondary control valve. And as you can see, there's some blue oil pressure, that blue color, on the bottom of that control valve. Well, that oil pressure is controlled by a pulse width modulated solenoid. So that solenoid then controls the pressure going into that passage in number 5 pulley to control the dimension of the number 5 pulley. So what's going to end up happening is I make the number 5 pulley smaller, I'll make the number 4 pulley effectively larger in diameter. So we're going to basically be able to work this thing and move the ratio from the low speed to high speed. If we want to reverse that, we simply reverse the 2 pulley positions. So here's showing us moving the pulleys the opposite direction now. We're starting out again with the number 4 pulley very large, the number 5 pulley very small. So I simply reverse the position of that stepper motor, which reverses the position of the valving, which in turn then gets rid of the pressure, as you can see here, in the number 4 pulley, adds some pressure to the number 5 pulley, and of course we end up with this thing changing position. So again, the number 4 pulley is going to get smaller in diameter, the number 5 pulley is going to get larger in diameter, which will in turn change my ratio again. Going to give me more torque. So that's the basics of how it works. So as you can see, there's not a whole heck of a lot here. A couple pulleys or hydraulic pistons is all they are, a couple valves, and a stepper motor and a solenoid. That's the gist of how most of this stuff works. Now there will be 4 types of fluid pressure within the CVT. As I told you guys when we first started out, you're going to have a couple variable pulleys here. You're going to have this stepper motor, and then you're going to have some solenoids on this transmission also. Well, one of the solenoids we looked at, that was the one that controlled that secondary regulator valve to control that secondary pulley. There's also going to be some other pressures that you're going to have because you're going to have some other things you want to control. So as you can see here, the primary and the secondary pulleys, the actual pressure that applies them is quite high, 750 pounds. So bottom line is we need to make sure that that pulley has enough pressure applied to it to make sure the belt stays tight and it doesn't chatter on the pulley or slip on the pulley. The second fluid pressure, as you can see, is what we have for the forward and reverse clutch. It maxes out at 218 psi. So it's regulating it to a maximum of 218 pounds. Third pressure, as you can see, is TCC pressure. It's maxed out at 145 pounds. So bottom line is we're going to vary the duty cycle on the solenoid to control the pressure of those 2 circuits we just talked about. Finally, you're going to have your fluid pressure for your lubrication and cooler circuit itself. Maximum pressure on that thing somewhere between 55 and 60 psi. So that kind of gives you an idea of what's actually going on in this transmission. So effectively, you're going to have some additional solenoids that we haven't talked about yet they're in charge of controlling these other pressures and the operation of these other components like TCC and clutch operation and so forth. When you look at the valve body, this is a layout on this valve body. As you can see, we got several valves. Again, valve wear has become an issue with a bunch of these CVTs, so pay attention to that. We rotate the valve body 90 degrees. You see the solenoid regulator valve there. We rotate it another 90 degrees, and you're going to see the other valves that are in here. Again, most of these valves, as you can see, are regulator valves. They're used to regulate a pressure for something. And then finally, you see the manual valve there, number 5. Now, one of the things I did in your handout was, as you will see when you open it up, is I give you an explanation of every valve in this valve body. What does that valve do? What kind of pressure is it set at? So as you can see, we're talking about the ratio control valve. What does it do? Secondary valve, what does it do? So again, we looked at the valves, so you've seen a picture of the valves. This is the text that goes with those valves to show you the function and operation of those valves. Here's the rest of the valves. As you can see, we've got several other valves. This would be the other side of the valve body we looked at right here, with the lockup valves and manual valves and all that good stuff in it. And finally, we got to look at the solenoids. As I told you, there are several solenoids on this transmission. The first one we talked about was that blue pressure. That was your secondary pulley control. So that was the variator control, and that was done by a variable force solenoid. So in other words, a pulse width modulation solenoid that actually controls the pressure going into that pulley. Line pressure solenoid, couple lockup solenoids, and so forth that you're going to have in this transmission itself. So bottom line is the vast majority of these solenoids are pulse width modulated solenoids. You've only got one, as you can see here, that's your select solenoid that's an on-off style solenoid. We give you a layout for the check balls and the screens, so you'll know what check balls and screens go where. And now we're down to the crux to this whole thing. Let's look at the electronics of it. Here is showing you the valve body that Jatco has for this transmission. As you can see, we're basically highlighting all the different solenoids and so forth that you've got. There's two things I want to bring your attention to. First off, number 7 and number 8 on that picture. They're at the top of the page. Number 7, that's the stepper motor we talked about. That stepper motor moves in and out to control that link that you see there, number 9, which in turn then controls the position of the ratio control valve, which is number 8. So that's the basics of how we make the pulleys work. We move the stepper motor, that little link pivots and pulls the valve out or pushes the valve in. Now the other thing I want to bring your attention to is extremely important. This is number 10 in this picture. It's called a ROM. That stands for read-only memory. So built into the ROM, and again, this is not the only transmission to do this. A lot of Jatcos have this. Some of the Mazdas have this. Some of the Subarus have this. Here's what they basically do. They program in to the ROM the flow characteristics of the solenoids with that valve body. That's why you cannot buy the solenoids separate from this whole assembly you're seeing from anybody. I'm sure some aftermarket source will probably service it, but the bottom line is if you went to Jatco in Europe to buy this, you'd have to buy the whole thing that you're seeing right here. There's a logic behind it. They program in the flow characteristics of the solenoid into the ROM. And then when your computer connects to that ROM, it reads the flow characteristics of the solenoid so it can then command the correct current flow through the solenoid to get you the right output pressure. We're doing this in lots and lots of transmissions. 6R140 comes to mind is a transmission we're doing this on. We're doing this on the new GM 8-speeds that will be coming out this summer. They all have flow-controlled solenoids built into them. So bottom line is, guys, that ROM contains your calibration information for the flow characteristics that were put in this thing at the plant for Jatco. And you're going to have to be able to learn that ROM. So if for some reason you change a valve body on here, you have to go through a learning process to physically relearn the PROM itself. So bottom line is, guys, the solenoids themselves, you're going to replace it as a valve body because they do not service this thing separately from having the ROM with it, and there's a reason by that. So we got a little comment that says, did you know the shop price for a factory unit with a 3-year warranty is only $1,750 to $1,800? No, I didn't realize they're quite that cheap, but that's a pretty good price on the thing. So Good to know that. Thank you very much. All right, so now let's take a look at a little more of the electronics, because even if you decide to put a factory unit in, you're going to need to know this other information. So here we go. We're looking at the solenoid, obviously pass-through connector, as you can see here. I'm giving you the resistance values of everything so that you know what you're supposed to see. I'm going to give you a couple of schematics so that you know which pins are going to where on this thing. So here's a little better schematic. And you'll notice there's actually a note I put in here. It says if you install a new TCM, a DTC 1679 calibration not learned will set, which also requires recalibration using a scan tool. There's a bunch of characteristics you need to know about, and I don't know how many of these CVTs I've had guys talk to me about at the seminars, but more than I can count, who have had complaints. They put a unit in the vehicle, or they replace the TCM, and this unit physically doesn't want to work. It just will not get out of its own way. Very sluggish operation-wise, just doesn't want to work right. What they don't understand is you have to relearn the ROM on the valve body for that particular transmission you put in, and you have to install a updated flash calibration to make sure that you in turn have the correct cal for that particular vehicle. If you fail to do either one of those, this thing is going to be a lead sled. So bottom line is that you do need to know that information going in, and we're going to really concentrate on that heavy for the rest of the webinar. Looks like I get another comment that says, will there be a webinar on every unit with the solenoid shift that that cannot be swapped? You mentioned the 6R140s. 6R140s, you have to know the flow rate of the solenoid. It's stamped on the solenoid. And there's also a process you actually go through to load a valve body cal if you in fact have changed the valve body out on that 6R140, or you swapped in another transmission into the 6R140 application. We're covering that in depth in the seminar this year. So if you guys are Pacific Coast time, I've got a seminar coming up. Obviously, we're going to be having one in San Francisco at the end of this next month. I've got one in Coeur d'Alene at the end of this month. I've got one in Vancouver, BC coming up in June. Trying to think what else we got one coming up. Los Angeles is going to be in August. So you'll have a chance to actually see how you actually do that process. We spend probably an hour actually in the seminar itself taking you through on a 6R140. What do you do if you have somebody change parts out? So a real good bit of information for you. Hopefully that answers your question. All right, TCM in this transition. As you can see, TCM on this application's upper left-hand corner of the dash area itself. And now we're going to talk about this TCM and replacing the TCM a little bit. Notice I've highlighted this area. Here's the highlight right here. It says when the ignition key is turned on the first time of reduction, TCM learns the values stored in the chip. Well, the chip I'm talking about is the ROM. So my point is the TCM goes out, it pulls the ROM, finds out the cal information that's in the ROM for those solenoids, and then it knows what lookup table to go to control the pressure correctly. So that's really important that you know that. It says TCM replacement requires a flash in service. Now I cannot overemphasize that. The TCM, as you can see, is a generic TCM. There's only going to be one part number serviced, and it has minimal functionality. It won't run the transmission. If you do drive it, you take a very, very good chance on damaging the transmission. It will be in default mode, and it will literally not get out of its own way. And we're not just talking about this particular CVT. There's tons of these Jatco CVTs out there used in other different manufacturers. I've ran into this numerous times with the Nissan units. So again, two things you got to do. You've got to relearn the ROM, and I'm going to show you how to do that. And then you have to recalibrate the TCM itself with the updated part number for the cal. So bottom line, guys, is you got to know what you're doing. It's a real simple process, but you got to know what you're doing. So I'm going to give you several scenarios here, and these will be right in your handout. So I tried to go through and find out each different scenario and what you'd actually do if you did something to it. So let's say, for example, you decided you're buying a reman CVT from Chrysler or whoever it happened to be, and you're putting a TCM in it at the same time. You got to do two things. You got to learn the ROM in that new CVT because that new TCM doesn't know what it is. You're going to do that by cycling the key on and off in a specific sequence. And then you have to install the calibration. That's called service flash. So you've got to do both of those or this thing will not work. Now the second scenario, as you can see, is a new CVT but the old TCM. So in this instance, what you've done is you've bought a CVT from somebody and you in turn put it in the car. And now remember that valve body slash ROM is going to be different than the one you took out. So you have to relearn the ROM. You then also want to go through and check the cals off of the Chrysler website to see if there are any update calibrations that are available from Chrysler. If there are, you're going to want to install those cals. Now, third scenario, as you can see, an old CVT and a new TCM. So in this instance here, you've got the old transmission, you repaired it, but you decided, hey, you know, all was bad with it was a bearing, because we said that's the number one failing item is a bearing, and for 40 bucks you can buy a bearing and fix it. So you fix it, but you decide you're going to put a TCM in it. So you put the TCM in it, it has to be learned for the ROM. In other words, you got to go through and physically learn the ROM again, and you're going to have to recal it because it has no calibration in it. So my point is the new TCM does not know the ROM that's in that transmission, nor does it even know it's a transmission controller. It is not programmed to operate and vary those pulley dimensions. So again, this transmission will not get out of its own way if you try driving the car without installing the calibration. Last scenario, old CVT and an old TCM from some other vehicle. One of these brother-in-law deals, the guy says, hey, I don't have any money, I'm going to go to the salvage yard and get you a TCM and get you a CVT. And you, of course, said, okay, fine, do that, bring it in. Chrysler does not recommend people doing that, but if you do that, you got to go through and relearn the ROM, and you have to install the updated calibration. Again, Chrysler does not recommend people doing that because, again, there's been a lot of troubles because not only does this TCM have to interface with the transmission, it has to interface with the other controllers on the data bus. So it does VIN code checks and bit checks and all sorts of other stuff. And so their whole point is you can get yourself into a lot of trouble by swapping out a used TCM in a lot of different vehicles. And, you know, I think we talked about that in a couple seminars ago. So bottom line, guys, there's a lot to know when it comes to swapping these parts. It looks like we got another question that popped up. The question says, when are we going to have the seminar in Vancouver? Well, I'm going to tell you exactly the date of that. That is May 31st in Vancouver, BC, is when the ATRA seminar will be. And we'll be taking you through all the stuff that we just talked about, plus a whole bunch more stuff. She's a full-day seminar for you. So hopefully we'll see you on the 31st of May. So anyway, back to our CVT here. I've also given you in your handout, when you print your handout out or obviously pop it over to your computer, you're going to have a listing of all the different trouble codes that the CVT has. There's a couple of different pages of them, as well as what the controller looks at to actually set the different trouble codes themselves.